Okay, we're going to start our final lesson here on perpendicular lines and parallel lines. And so let me start off by reading the definition to you: perpendicular lines and slopes. So a perpendicular line is two lines in the same plane that intersect to form right angles, and those are perpendicular lines. Non-vertical lines are parallel if and only if their slopes are negative reciprocals of each other. So let's look at that definition and let me ask this question. Are these lines perpendicular? Well, going back, it says they would need to form right angles, 90-degree angles. So if you look at these lines here, you can see the slope is the same. So they wouldn't be perpendicular. In fact, in order for them to be perpendicular, the lines would have to be opposite and reciprocal. It looked more like this. And that would be a perpendicular line. So looking at this one here, what would be perpendicular to just the y-axis, or a straight line up and down? Well, it would be the x-axis going straight across, right? So that would be a perpendicular line because it would be opposite or negative and the reciprocal of it. So let's look at some examples on how we can find a perpendicular line. So look at these lines. I have line A, B, and C here. And what would be perpendicular to these? Well, in order to find out if these lines would be perpendicular or are even parallel, you can do it in two steps. First, you need to solve for y, put it in the slope-intercept form, y equals mx plus b, and just look at the m's. And if the m's are opposite reciprocals, then they're parallel. But if they're not opposite reciprocals, unless they're the same ends, if they're opposite reciprocals, they're perpendicular. If they're the same ends, they're parallel. So let's look at it real quick. This one already is solved for y. Y is already by itself. It's done. But in this one here, we need to solve for y and see what it would be. Sorry, this x kind of faded into obscurity. So let's solve for y by doing a negative x to both sides. We'll bring down the 4y equals a negative x plus 3. We'll divide both sides by 4. And then what do we end up with? We end up with y equals a negative 1 over 4x plus 3 over 4. Now this whole b here for the y equals mx plus b is not what we're even looking at. We're only looking at the m. This m is a negative 1 over 4. This m is a 4. So would they be opposite? Well, one's negative and one's positive. Would they be reciprocal? Well, one's a 4 and one's a negative 1 over 4. So yeah, those would be perpendicular. But let's see if c fits into this. So what would we do to both sides to solve for y? We would do it positive 2x, positive 2x. Bring down the 8y. And then divide by 8, both sides. And we'd end up with y equals 1 over 4x plus 2. Okay, so again, all we have to look at is the m, the 1 over 4. Well, that's a 4, and that's a 1 over 4. So they're reciprocals, but they're not opposites, so they're not actually perpendicular to each other. So just a quick remember is that the product of a non-zero number m and its negative reciprocal needs to be negative 1 if it is going to be a perpendicular line. So if you were to multiply two numbers and it ends up being a negative 1, then it's reciprocal. Okay, last thing, summary. The summary. So if it's parallel, you have the same m's. The lines would never touch. Same slope. If m was 3 on one, the m would be 3 on the other. For perpendicular, they're going to cross at 90 degrees angles, and then there'll be negative reciprocals of each other. So if m was a 3, for it to be perpendicular, m would be would equal a negative 1 over 3, And if you were to multiply those together, 3 times negative 1 over 3, let's see what we get. 3 times negative 1 over 3 would equal a negative 1, and that's kind of my way of knowing 100% that they're perpendicular.